Okay, so this is part 3 of lecture 5, and it is naming rules. There are different rules depending on if you were talking about ions or covalents. There are a couple of specialized rules for the ionic compounds because of those elements that can have more than one charge. You have to tell the viewer or the listener which form you're talking about. You're talking about copper 1 or copper 2, for example. You can't just say copper oxide, because copper can connect with oxygen either as a copper 1 or a copper 2 ion. The other area, of course, is the polyatomic ions. Those ones where you have more than one atom involved in that ionic structure. So monoatomic, meaning there is one atom, mono meaning one. We squash the O and the A together. So monatomic ions. If it's a cation, it's simple. It's the name of the cation. The cation is the metal, the left-hand side of the periodic table, and the word ion. Super easy. Magnesium ion, aluminum ion, calcium ion, barium ion, potassium ion. Remember, K is potassium. It's just the name of the element and the word ion for cations, for positively charged ions. Singles, we're talking about single ions here. If it's an anion, you add the ending, the subscript IDE. So for a negatively charged single ion, oxide, nitride. So this is nitrogen. We kick off the ending and we add IDE, nitride, oxide, chloride, fluoride. So these are your basic naming rules for ions. So be sure to know these. These are the most common ones you're going to find. We're not going to deal with this. Maybe this is selenium, so it would be selenide. So yes, you might see that. Cesium, rubidium, barium. Now don't get these. This is beryllium, like berry. This is barium, and then boron is over here. So be familiar with these. When you say the formula unit, remember you write it with the cation first and then the anion. And so you say it the same way. You say the cation element, sodium, and then chloride with the IDE ending. If it's polyatomic, which rules we're getting into, you would say the sodium and then the polyatomic name, which in this case is nitrite. So it's simply the cation first and then the anion. IDE if it's single. If it's polyatomic, you have to follow those rules. All right. Be sure as we go into these polyatomics, it's a common mistake is you start working with the polyatomics, like sulfur is in combination with oxygen here as a sulfite ion or sulfate, and then you get sulfur ion by itself, and you forget you want to apply these naming rules. No. Sulfur by itself as an ion is a single element, and so it follows these single element rules and sulfide. So watch for that because it's a really common mistake to do. As you start going on naming these guys and all of a sudden there's a single sulfur, it's like, wait, where does it fit in the naming rules? It's back to the other simple anion naming rules, IDE. This particular type of polyatomic is called an oxyanion or oxanion. The other one has a Y here, I call it that, because it's a polyatomic anion that has oxygen. multiple oxygens. So this is 1 sulfur and 3 oxygens, 1 sulfur and 4 oxygens. And there's a really great video I'm going to show that will help you remember this, because it's tricky to remember otherwise. First, let's go to, okay, this is from the periodic table. Here's boron. These are your nonmetals: carbon, nitrogen, oxygen, fluorine, silicon, phosphate or phosphorus, sulfur, chlorine, arsenic, selenium, bromine. We're not going to use this. And iodine. These are the polyatomic anions you are going to want to know. However, you do not have to memorize all of these. There is a pattern, okay? So, you need to memorize the ATE version. And the little video I'm going to show you will give you a trick to remember that. So your ATE, sulfate, chlorate, nitrate, that's your core form. So I'm going to go to whiteboard. Okay. Okay. So you need to memorize the ATE form, which is your core form of each of these. Because what changes after that, let's try that again, is the number of oxygens. That's all. The charge does not change. So this is your core. So let's say, well, chlorine is, by the way, heads up, chlorine is most commonly used in tests because it has all of these steps I'm about to show you. So chlorine is Cl, chlorate so we've taken chlorine, I took off the INE, the ending, and I put in chlorate. It's the chlorine, oxygens, and a charge. The number of the charge is not going to change as you go up and down this. The only thing that changes is your number of oxygens. So if you lose an oxygen, you go to ite. So that's chlorite. And what have I done? I've lost 1 oxygen. I had 3 there. I now have 2. Everything else is the same. All right. What if I lose 1 more? It happens with this guy. If you lose 1 more, you're going to keep this ending, but you're going to add hypo to it. So if I lose 1 more, what have I got? I got ClO. That's it. I don't put the 1 down there. And I keep my negative charge. That's the only thing I'm changing is the number of oxygens. And this is hypochlorite. It's this, stick a hypo on there. That's what you call that. Okay, let's go back to our core. This is the core. I need more colors. That's my core. This is the one you have to remember for every single one. After that, you just step up or step down. So what if I add an oxygen? Because for the chlorine, you will, which is why we like to use it. If you add, you're going to add per. You're just sticking that on the front. So I'll use green for that again, I guess. Wait, purple. So I'm adding an oxygen. So what is it going to look like? It's going to look like ClO4. Same charge. Charge does not change. And I need another purple marker. And so what is this called? Well, if that's my ATE, if that's my core, I just add this on front of it. So it's per chlorate. Okay? So this is your rules for naming polyatomics, these oxyanions. You start with the ATE, know that. Not every element is going to have this entire per to A to I to hypo. Bromine does, chlorine does, and so we use these. Iodine does. But all you have to know is this one and how many oxygens it has and what the charge is. And then remember, if you add one, you step up to per. If you lose one, you change, you go from 8 to ite. If you lose one more, add a hypo. You're going up and down the staircase. And that's all you have to do to change these names. So I would recommend when you go to take the test, scribble this down somewhere as soon as you sit down to take the test as a reminder, and then just walk through this little staircase of rules. Now, I'm going to show you the video. How do you remember this? Because if we go back and look at that slide, number 31, it can be a little overwhelming, and it is hard to remember, which is why the video is so fantastic. See, you've got the core. Some of these you'll use so much you'll remember it. So the ATE version of sulfur has 4 oxygens and it's a -2 charge. Notice that sulfur sulfate doesn't have a persulfate. Doesn't exist. So not all of them have all forms. That's why just remember this, and then you're asked a question, either what is sulfite? Well, if you remember what sulfate is, you can remember, I just lose 1 oxygen. And remember, and notice, see, there's my sulfide. It follows the other rules. There's my chloride. And when you start going up and down these steps, you're working a lot of these, you get in that mindset of following these rules for naming, and then you get to like a sulfide and a bromide or a chloride, and your brain wants to use these rules. But no, this single standalone ion follows the old rules of just the IDE. All right, let's go to that video. I find it when I just go to YouTube under the T43 method. And there's also another one called the T41, but I really like this one. So let me show you random tutorials, but I like it. It's not the fanciest, but to me it's the most, oh, I didn't share that, sorry. Let's try that again. Makes it a lot different if I share it. All right. So here's the name of it on YouTube, but I'm going to play it so it'll be part of this video. It's only 2 minutes. I'll put closed caption on, and I know it helps me, so here we go.
T43 method for remembering polyatomic ions. First, notice the staircase. The staircase is used to separate metals from nonmetals, and in this case, work as a guide for our method. Start off by penciling in a T. The T goes across boron, carbon, nitrogen, and silicon. Next is the 4. The 4 is phosphorus, sulfur, arsenic, selenium, and tellurium. Next is the 3. The 3 goes over chlorine, bromine, krypton, iodine, xenon. Now, all of these polyatomic ions contain oxygen, pencil in an O next to each element. How many oxygen atoms are in each polyatomic ion? The T4-3 method will help you figure that out. T is for 3. That corresponds to the amount of oxygen atoms. Everything in the T has 3 oxygen atoms, ions. Each 4 has 4. Finally, these 3 have 3. Next is charges. The charges are simple. 4 restarts it, and you start on 3, go to 1. Going from the top, 3, 2, 1. This is a 2 here, this is a 2 here. So you just drop that down. Next is this row. It's 4, so it restarts. So you go to a 3, 2, 1. Drop down a row. 3, 2, 1. 2, 1. Going out of focus there. Jeez, camera, calm down. And that's the T4-3 method for remembering polyatomic ions and their charges.
So let me make sure that's not going to.
Okay, so this is a quick trick to help you remember all of your
Stop.
oxyanions.
All right. So there are other videos of the T43, also called the T41 method, you can look up, but it's extremely helpful because remember, that periodic table is always available to you. So use that to help you remember. This gives you the ATE form of your polyatomic ion. So you do T43 and you look up for sulfur, for example. Where does sulfur fit on that? Oh, it's on the 4, so it has 4 oxygens. Count over, it's on the second, the 2, the 3, 2, 1. It's a -2 charge. And it really, really helps. Like I said, I use it. Okay. Back to our slides. This is probably one of the more difficult things to remember in this semester is the naming. But these methods will help you simplify it. So let's go back over this slide a little bit. A single oxoanion, I call it oxyanion, it's the same thing, is the ATE. And you go down, you lose oxygen, you lose 1 oxygen, it's ITE. You lose 1 more, it's hypo, ITE. If you are at ATE and you gain an oxygen, it's per ATE. So up and down the little structure. Here's an overview. Something else to look at. Most of the polyatomic anions you're going to get are oxyanions. However, there are a few exceptions. We have hydroxide, know this. And hydroxide is not HO, it's not ho, 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 it's not Santa Claus. It's O, OH. So when you write that, and it has a -1 charge. Cyanide. Here it is, ammonium. You definitely want to know this. Ammonia is NH3. Ammonium. These are examples of acetate. Acetate, cyanide, ammonium are examples of names that were given to these ions well before their structure was really understood. And so they're archaic names that were kept. So acetate, and this becomes acetic acid. So you want to know these. I think that's, you will get ammonium a lot. It's very common, okay. The other thing to notice that phosphorus and sulfur, the element name is phosphorus, but it doesn't change to phosphorate, it changes to phosphate. So it just makes it a simpler sounding word. Same with sulfur. It doesn't change the sulfurate, it changes the sulfate. So that's just a little extra thing. But you've heard those names before. You've heard of phosphate, you've heard of sulfate, so that should make it easier to remember. This slide is very, very helpful of just letting you know what exists out there, what you need to know. This is the whole corner of it. And then this slide is, once again, the variable charge, the elements that have more than one charge that you need to know. Silver and zinc are on here because it's easy to get them confused with the ones that have multiple charges. In fact, they don't. I call it A to Z. They have only one charge. All right, how do we name them? Like I said, you have to tell the viewer which form of chromium, of manganese. This is iron. The Fe stands for ferrous. It's the Latin name, but that's iron. Cobalt, copper. You have to tell the viewer or the listener which form is complex with, let's say, the oxygen or whatever it's in complex with. So we have to put that in the name. Now these are ions, so this is going to be for ionic bonding. So you simply write, normally when we have an ionic compound, it's the cation and the anion, IDE. So magnesium chloride, for example, sodium chloride, sodium fluoride. But if it's one of these that has more than one charge, you have to put in Roman numerals, in parentheses, which version it is. So if the cation involved has the 2+ charge, it's just because it does, that's what exists, and you have to tell us that. You would write it like this. Chlorine has a 1-, and so you have to have 2 chlorines for every iron. But if I just say to you, iron chloride, that tells you nothing. You don't know which form of iron. So I have to say iron 2 chloride. I have to tell you that this was the 2+ version of this ion. If I use the 3+ form of the iron, you have to say iron 3 chloride. Now you can look at this and see for yourself which charge, because you know what the charge is for chlorine. But if you're saying it, or you're only given the name and you have to write the formula, you have to have the Roman numeral in there. So the Roman numeral is only for elements that can have more than one ionic form, which is the previous slide. So make sure you know those. You guys are lucky. You don't have to learn it this way anymore. This is the way I learned, was we didn't use the Roman numerals. We changed the endings of these as well. So you will sometimes hear me call it ferrous chloride or ferric chloride or nitrous oxide. You'll hear me say that because this was the way I learned it. Way back in the dark ages, right? So now they've changed. This is one of the few things that has changed in chemistry since when I first took it, is now they've simplified it and you just use the Roman numerals to indicate what the charge is. If you see this tin 4 oxide, you know that tin has a 4+ charge. Oxide always has a 2-, and then you put together your chemical formula based on that information. I'm not going to go through all these. However, the next set of slides are very useful. I would recommend going through them. You can always look them up online to get the answers. Just Google them. That one gives them to you. I would definitely recommend working through these to help you remember. Naming is the type of thing, the more you do it, the more you'll remember it. So work through these. Write down your own answers and then look them up to see if you're right. And like, for example, here's that ammonium ion I told you about. Notice it has a parentheses around it and then a 3, because this has a +1 charge, the whole unit. The nitride ion has a 3-, and so you have to have 3 ammonium ions for every 1 nitride. So you have to put parentheses around this unit and the 3 goes outside of it. Because ammonium does not have multiple charges. It only has a +1 charge. You don't need Roman numerals. All right. Then the other thing is covalent. Because covalent molecules, non-metal plus non-metal, your combinations, your carbons and oxygens combined, isn't based on an ionic charge. So you can have all different combinations. So you have to use the nomenclature in this case tells you how many of each are in your formula. So what gets written first? It's going to be the element farthest left on the periodic table. So if you have copper and carbon and oxygen, you go look on your periodic table, carbon is further left than oxygen. So you would write your carbon first and you would say your carbon first. If you only have one, it's simply the element, phosphorus, hydrogen. The ending element again has IDE. So that rule is the same for both the ionic and the covalent. But because the combination here is not based on any kind of charge, it's simply based on the way this molecule formed, and it can have all different arrangements. You have to say there are 5 chlorines, and 5 is penta. Go back here a minute. So you have to, excuse me, you have to memorize the, and I'm looking for the rules. There we go. Okay, so you have to memorize the prefix for each of the numbers, 1, 2, 3, 4, 5, 6, 7. We rarely say mono. We only say mono if it's an archaic like carbon monoxide. So as a rule, we don't say the 1, we don't say mono, we just assume. So we don't say monophosphorus pentachloride. You just say phosphorus pentachloride. But if you have more than one, even at the front one, you have to say, so this is triselenium, because there are 3, dinitride. IDE, because it's the second element. So triselenium dinitride. So here are some examples to go over. It's a good idea to cover the names, try to name these on your own, and then check your answers. Now, be careful because here's the nitrogen-oxygen combination. Now, we just saw in the polyatomic ions, NO3, nitrate ion. That had a charge on it. You know if it's a polyatomic ion because it's going to have a charge on it. It's an ion. If you do not see a charge, it's not an ion, it's a molecule. And you treat it accordingly. So practice those. There is no charge on here. So it's dinitrogen. It's the first element, so we just say nitrogen. Tetroxide. You squash it together. So this just requires practicing. You should have plenty of Alex homework. An exception here, 2 exceptions. One is the archaic I was talking about. Come on. Down at the bottom, which is, we still use water. We don't call it H2O, we call it water. The commonly accepted names, sucrose, ammonium. Okay, that's an ion, but so just like there are some ions that we use, we've carried over archaic terms because they're common, the same thing with molecules. So there's the ammonia. The ammonium ion has 4 hydrogens and it has a 1+ charge. This has no charge. This is a molecule, and it's ammonia because it's archaic. If you have a hydrogen, we don't say dihydrogens. We don't use the prefix for hydrogens. Hydrogen always has a, you can always determine how many hydrogens they are by what it's with. So hydrogen is very special. She has a lot of her own rules in everything that she is used for. So just hydrogen special, just use that as your reason. And hydrogen does not get a prefix. It's just hydrogen sulfide. We'll just leave her like that for now. Okay. So covalent molecules exist, and you take the way it exists and then you name it accordingly. All right, I went over that. So here is your table of prefixes that you need to know. So memorize these. And these are just some examples. Watch out for this one, sulfur trioxide, because if this were to have, if this had a charge on it, SO3 2-, that would be a polyatomic ion, and that would be sulfite ion. So watch out whether it has a charge or not. No charge means it's just a molecule, and you name it accordingly, sulfur trioxide. If it has a charge, you go back to those rules you will have memorized, and the T43, and you say, oh, that's sulfite ion. So watch for that charge. Okay, again, just work through these, practice these. Hydrogen peroxide, that's another common phrase. It's not hydrogen dioxide, we call it hydrogen peroxide. All right, let me see. Go down, see. Okay. The last bit is naming acids. Now we are going to have an entire separate section on acids, but I want you to be familiar with the naming. The naming of them is very similar to the rules for your ionic compounds or your polyatomic ions. Acids are covalent molecules, hydrogen and chlorine, hydrogen and fluorine, that react with water and create ions. Like I said, we're going to have full sections on that towards the end. They're generally written with the H in front. And you can either have binary, which is only 2 elements, a hydrogen and something else. Binary means 2. It means 2 different specifically. Like computers code in binary 1s and 0s. It's the same concept. So if it's binary, you just, the element name will end in IC. So ic, fluoric, chloric, bromic, like that. But the H you can call hydro. So this binary HCl is hydro for the H, chloric for the chlorine, and then follow it with the word acid. It's a full sentence. So binary is just hydro, the ending of the element with the ending ic, acid. So hydrochloric, hydrobromic. I usually remember this just because hydrochloric acid is so familiar. I use that as my linchpin to hang on. If you work with the more complicated acids a lot and then you go back to this, your brain can go blank. It's easy to remember hydrochloric acid. That's so common. It's always right there in the brain. So I actually use this as my memory jog. If I have to name HI and my brain goes blank, I go, oh wait, HC, hydrochloric acid, hydroiodic acid, right? And then I follow the rules. When you do polyatomic, so let's go back to my board. See, this is still up because polyatomic, these can also form acids. And the naming is from the same. So this is chlorate. If it's an acid, that's ClO3. But if I put an H in front of it, now H is going to be one charge. So I'm balancing out this negative here. So it's going to take one H. All right. Now I have an acid. 8 is going to be replaced with ic, and we call acid. So chlorate, my ion was called chlorate. This is going to be chloric acid. So the 8 replaced by ic, and you say with the word acid. So chlorate, if it's in an acid with a hydrogen, it's chloric acid. What about the ite version? You replace ite with us, O-U-S. All right. Do you see that? And so chlorite, which is this guy, we're now going to turn it into an acid by putting the H there. And it's going to be chlorous acid. So you're just changing the ending. You follow the same rules for the polyatomic ion. You change the ending. 8 gets changed to ic, ite gets changed to us, and you add the word acid. You keep these guys. So perchlorate for the ion will be perchlorous acid. Perchlorate acid. I shouldn't just, brain's getting tired. So the 8 is still ic. So perchloric acid. The ite becomes us. Hypochlorous acid. So 8 becomes ic, ite becomes us, everything else is the same, and you say the word acid. Both cases you say the word acid. Hydrochloric acid, chloric acid. So practice these rules. You should have plenty of Alex homework on it. And you do need to know how to name acids. But again, with practice, it's easy to pick up. So you have 2 different naming styles for acids. One is binary, meaning you have 2 elements, binary. That's what binary is. It's just going to be the hydrogen and something else. So the hydrogen, we say hydro, and you change the ending to ic. So hydrofluoric and say acid. Even though there are 2 hydrogens here, it doesn't matter. Just hydro, sulfuric acid. If you have the polyatomic, you follow the polyatomic rules. So this is carbonate. So 8 goes to ic, carbonic acid. Okay, so practice these. It really just comes with practice. Here was another flow chart that you might find helpful for naming. Maybe keep this up while you're working with your homework or something, or print it out. That's naming your compounds, and that's naming acids. All right, we're not going to do organic compounds. Just real quickly, if you see anything that ends in OL, the name, fly buzzing around, OL, methanol, ethanol, butanol, anything that ends in OL is an alcohol. An alcohol has an OH group in it, and that'll become when we get into solubility, that will become important. But it's just alcohols, OL. If OL is in the name, it's alcohol. If OSE is in the name, sucrose, fructose, glucose, that's a sugar. So we'll look at that again when we go into solubility. That's just a little side thing that if will help. Okay, we're not going to do any of that. All right. Okay. Practice, practice, practice. That's the best way to do naming. And yeah, ask questions, but mostly practice right now. And if you get snarled up on something, definitely shoot me an email or ask during lecture. But most of the naming, it's just a matter of the more you do it, the more comfortable you'll become with it. So that is the end of lecture 5.